Hello everybody, today we're going to start on the second set of notes, which I'm going to call day 2, even though we're not going to get into it. So last time we did direct variations, which was the equation y equals kx. Today we're going to do inverse variations. We're going to do the same types of problems. The only difference here is that we're going to use a different formula. So it's still got the k and all that fun stuff. It's very, very similar to direct, almost too similar, and you're going to see why in a second. So make sure you pay very close attention to the details. That's what's going to get you. All right? So let's go ahead and get started. So an inverse variation is an equation of the form y equals k over x. So not k times, k divided by x. Where k does not equal 0, and it has a constant of variation k. So k is still doing the same thing. It's telling you the relationship between the x and y. So very similar to direct variations, we can find the k the same way with just one ordered pair, giving us an x and a y. We can figure that out, which means we'll get our equation. Okay? Where it differs a little bit is the shape of the graph and what's going on for it, and the relationship. So, but we're still going to find k the exact same way. You just get k by itself and plug in x and y, and you'll find that, and that way you have your equation. All right? So the inverse variation graph tends to look like this, where it's two curves. So they can be in the first and third quadrant. They're opposite of each other, or they could be in the other two quadrants. That's fine, but they're never going to be in a quadrant next to each other. Okay, they're always going to be the opposite across the origin from each other, and they curve. They don't cross any of these axes. Okay, you need to know what the graph looks like for an inverse. Not if it's the exact graph, okay, but you should be able to recognize, like, if I give you a graph and it looks like this, oh, you can be like, oh yeah, that's an inverse variation. You will never have to actually produce a graph for an inverse variation. Okay. And it's because the points are very hard to find, and they do this curve thing, so they will never actually cross. It's very complicated to draw. Okay? The inverse variation formula, like we said, is y equals k over x. So it's going to be a number on the top, and the x will be in the bottom. It's not x over a number. It's not like that, because we can rewrite that, like you guys saw on the notes from direct. And that would be a direct variation. When it's a number over the variable x, that's an inverse. The constant of variation, the k, the way you would find it would be doing x times y, because that's how you would get k by itself, by multiplying both sides by x. Okay, this is different than the direct, even though it looks pretty similar. It's different than direct. Direct requires you to do y divided by x to get k. Inverse just requires you to do x times y to get k. Told you they're very, very similar. Okay, put these two on flashcards and, like, check the flashcards like every night so you don't get them confused. Okay, so here's an example. You have to identify if it's direct, inverse, or neither. Okay, and in order to do that, you're still going to do the same thing as like we did the other day. You're going to get y by itself and see which one it looks like. Okay, so here I gotta get x, or I gotta get this y by itself. So I'm gonna subtract 2x from both sides. So now I have 3y equals negative 2x plus 5. I'm gonna divide everything by 3. So I get the equation y equals negative 2/3 x plus 5/3. Yeah, there we go. If it didn't have the plus 5/3, it would look like a direct variation. Okay? It doesn't have x in the denominator of a fraction, so it's not an inverse. It's not a direct because it's got something on the end. So this would be neither because it has a b. Okay? It shouldn't have a b in either variation equation. Now you're going to go ahead and try these two. Okay? You're going to have to get y by itself to be able to tell which one it is. Okay? If it looks like the equation for an inverse variation where you have a number over x, then it's an inverse variation. If it looks like a number times x, that's a direct variation. So go ahead and give these two a try. Example 2, to tell if it's a direct, inverse, or neither, with a table, you're going to do the same thing. So with direct, we would just find the k value for each one. you're still going to do that. So in order to tell if it's direct or inverse, you need to actually test all of them with direct and see if it's direct first. If it's not direct, then you want to test the inverse. If it's not inverse either, then it would be neither. Okay? But you're going to have to go through and be like, okay, I'm going to test direct first. Or I'm going to test inverse first. And try to find the K for the inverse or direct, whichever one you're doing first. And if you get them all, then you know the variation it is. If you don't, you try the other variation. So let me show you. So I'm going to test direct first because that's the one we already know. In order to find K for a direct, you would do y divided by x. So for each one, I'm going to do y divided by x. So 1/2 divided by 4 gives me 1/8. Here, I'm going to do 1/3 divided by 6 gives me 1/18. So it's not the same. So I know it's not a direct because I'm not getting the same K. So now I'm going to go test inverse. To find K for inverse, you do x times y. So 4 times 1/2 gives me 2. Do it again. 6 times 1/3 gives me 2. Make sure it works for everything. 8 times 1/4 gives me 2. So because they all get the same K's using the inverse equation, I know this is an inverse variation because all the K's match. Alright? You guys are going to try B and C on your own, so test one variation first. If it doesn't work, test the other one. Okay? Oh, and because, sorry, I almost forgot. Because I got the same K, I can write the equation. So the equation would be y equals 2 over x, because 2 is the K. So try it on your own. If you can determine if it's direct or inverse, write the equation for it. If it's neither, you can just write neither. Okay? The last one is an example. So this is a word problem. I'm just showing you a little bit each time. So it says the volume V of a gas varies inversely as the pressure P gets put on it. If the volume is 240 centimeters cubed under pressure of 30 kilograms per centimeter squared, I don't know the science of it, sorry. What pressure has to be applied to have a volume of 160 centimeters cubed? Okay, so here's the thing. First clue told me it was an inverse variation because it says it varies inversely. The second thing I need to know is x and y. So I could know a little bit more about science and know that if I put more pressure on something, the volume is going to change and figure out x and y that way. Or you could do the math way, which is the way I do it. It's always going to be y varies whatever to x. So y is always going to be listed first. So volume is your y, and the pressure that's put on it is your x value. So here, there you go. So they gave me some information. So they gave me 240 centimeters cubed, which is volume, which I said that's my y. And P, which should be an x here. That should be an x. Is 30. So I wrote that down. Yeah. So I could change it to x and y's, so I have those numbers. But remember, I'm trying to fill in this equation, y equals k over x, which I could rewrite to use the variables they gave me and say v equals k over p. Okay, either way works. It's up to you. If you want to change it to be x and y, it's totally fine. If you want to change it to be the variables, that's fine too. It doesn't matter as long as you put the numbers in the right place. So because they gave me two values already, I'm going to use those to find my k. So I plug those suckers in, and then I'm just going to solve for k. So I'm going to multiply both sides by 30. I get k equals 7,200. And if I knew more about science, this is a reasonable number, okay? If we were talking about like height and weight, this wouldn't make any sense. But because we're talking about pressure and volume and things that have to do with gas and science and everything, you want to trust your math. Like, so this is a possibility when it comes to science, okay? So I'm going to use that k value that I found to write my equation. So I'm just going to fill in the k in either of these, whichever one you used. So I actually used the VP one just so I can keep it straight. So now I have the equation that I would use for this. So if I'm trying to find out the P value when I have a pressure of 160, I'm going to plug in the 160 and then solve for P. Now P is in this denominator. I need to get that out of the denominator, so I multiply both sides by P. So now I have 160 P equals 7,200. And now I can divide everything by 160 in order to get it out of the denominator. Or not get it out, get it by itself. So I end up getting P equals 45 kilograms per centimeter squared. Now, interesting fact. Somebody yesterday, today, whenever you're watching this video, somebody in my class actually showed me a different way that they found the missing number, which is fine. I'm not saying it's wrong or anything, it's just a different way. What they did was, once they found the equation, they plugged it into their calculator and went to the table. That is a perfectly fine way of doing it now that you guys know how to use the calculator. I would prefer to see more handwritten stuff, just because the only reason is so I can check your work. And I can actually find out where you're making a mistake, if you are making a mistake, and correct you. When you guys put it in the calculator, I don't know what you type in. So if you are going to use the calculator for it, please write down like what you typed in where and like what buttons you're hitting, so I know where you went wrong on the calculator and I can correct that. Okay? And then you're going to have a try on your own. I didn't make it as real wordy as the other one. This one is just straightforward. It gives you the x, y. Same way you're going to solve it when you found direct. It's the exact same way, except you have a different equation you're trying to make. And you're going to have a different equation to find your k. That's the only difference. Okay? But that's it for the video. Sorry I was a little, I went off on a tangent for a second. But it's not too bad. If you have any questions, please write them down, and I will be happy to answer them next class. Other than that, I'll see you guys later. Bye!